So that's all. Okay. So we start. We'll have a very small and light session today. I'll not put in very heavy things. We'll just look at the nodes and the basic architecture of the IMS system or the IP multimedia subsystem, which is collectively used for the functioning of the VoLTE. Okay. Now, so all of us now by now we know what is a GT, how the calls are routed, and we have also seen that the VLR will supply the MSRN. Okay, the HLR will interrogate the VLR. The VLR will supply the MSRN, which is the mobile station's routing number. And once the handset or the mobile equipment moves from one VLR to the other VLR, what changes is its MSRN and not its MSISDN. And that is what makes roaming so easy in the GSM technology. So that is what makes it interesting, that the handset is able to roam into different VLRs without changing its own number, as because when the call gets routed or when that particular mobile handset receives an incoming call, it is allocated an MSRN. Okay. Now, in case of the VoLTE, we talk about the IMS system or the IP multimedia subsystem. So, the functionality of, now what is the basic function of the VLR? Let us again recapitulate. So the basic function of the VLR is number one, mobility management of the subscriber. So that means VLR knows the subscriber's mobility information. Now what do you mean by the mobility information? Mobility information means that under which cell he is updated. Okay. Now in the IMS, we have got our separate nodes which are taking care of this similar functionality. So when you start understanding the VoLTE architecture, first we will see how the system is designed, and then we'll go for the call flows. So good understanding of the system design will actually help you to comprehend the call flows, which we'll take up at a later stage. Okay. So in the IMS system, the IP multimedia subsystem, there are the different nodes which are actually mapping the functionality of the classical GSM, which we have already studied. So VoLTE, as it is abbreviated, is voice over LTE or voice in the 4G scenario, and it is quite different, technically, and in terms of its flows, it is quite different from the traditional what you call as GSM system. Now, how it differs, where it differs, and why it differs, this is what we'll study in the call flows. So after doing the VoLTE architecture and call flow, we'll take a session on the 4G technology. So I initially thought that I will take 4G technology ahead of VoLTE. But now what I feel is that you need to know VoLTE first. 4G technology can wait a bit for the time being, so we can come back to that at a later stage. Okay. Now, so these are slides which I have borrowed from my colleague, not only colleague, my very good friend in Nokia, who also would be working with all of you in different cases. So Amit Gupta is a very famous, VoLTE specialist in Nokia. So Amit has been kind enough to lend me his slides so that I can take up the Nokia architecture with you, because Nokia VoLTE is approximately 70% of our total VoLTE footprint that we have, and the rest is Mavenier. Though Mavenier is a much newer company, they don't have these type of slides and these type of things. So if you comprehend Nokia, you will be able to handle Mavenir as well. So that should not be a problem. Okay. Right. So here we go. So what we'll study? We will study number one, the VoLTE evolution, the evolution of VoLTE, how it was born, how it was comprehended. Okay. And then we'll see the classical network architecture of VoLTE. Then we'll see the components of the IMS system. And then we will learn about the different interfaces and the protocols. Then we'll go for the high-level VoLTE call flow. That's how the VoLTE MOC happens, and how the VoLTE terminating call happens. And another aspect of the call flow, which is a bit complex, that is how the CSFB happens. That's a circuit switched fallback happens. So circuit switch fallback means when a VoLTE subscriber moves in a non-VoLTE network, so his call falls back to circuit switch. It can also happen when VoLTE subscriber, the breakout out of the IMS system. So that can also happen when a VoLTE guy is called a non-VoLTE guy. Okay. So what are those scenarios? We'll take up later on. So you don't have to crack your heads about those for the timing. We'll just have a look at the evolution and architecture, the basic components. We'll try to look at it today, and then we'll go for interfaces and protocols maybe tomorrow. Maybe we can take another half a day to understand the architecture. So I'll not push in too much on you guys. Just we'll have a outwardly look. Okay. Right. So what is the missing link here? There's voice, there's SMS, there's IN services, there's policy control, there's multimedia. And now Nokia VoLTE, or the Nokia VoLTE system which we have here today, is able to take care of all these services, which classical 2G and 3G gives you. Only difference is that these services, okay, these services are given over a newer radio interface, which is the VoLTE. Okay. Right. Okay. Right. So we'll see here how it happens. So VoLTE is basically a technology which provides you all the services which you have in 2G, 3G. So if you're a VoLTE customer, you can have your voice calls, you can have your data, you can have your multimedia calls, you can have your prepaid services, you can do SMS. So everything happens in VoLTE. How it happens, who are the key players, that's what we are going to look into. Okay, moving on. Now, voice over LTE. Now, LTE is basically a technology. Okay, it is a long-term evolution technology, which we also call as 4G technology. So, how 4G technology is used to give voice services is what is determined by VoLTE technology. So, VoLTE means how 4G technology is used for voice. Okay. Now, what are the requirements for VoLTE? Number one, it has to have real-time traffic. Okay, real-time traffic means, as I was telling, I think, in one of the sessions, that in the IN system, what happens is the real-time charging. Means you are making a call and immediately your balancers are getting deducted. So VoLTE has to be able to support that real-time scenario. That is number one. Number two, another parameter which comes into VoLTE is the quality of service. Now, QoS is something which was not there in a 2G, 3G. Because as you know that in the 2G, 3G, it was TDM link. It used to happen to the TDM and pulse code modulation techniques. So, there you could not regulate the quality of service. But in VoLTE, since it is about packets, okay, it has to give you, it has to be governed under the QoS. Excuse me. Okay. Now, what is the requirement of real-time traffic and what is QoS? Now, there are two aspects of real-time traffic. One is the real-time realization of what is happening. This is what I was telling you about the charging part. The other part is the simple part. Simple part is when I am saying hello to you, your reply hello should also be audible to me. And when we are talking to each other, right, we should be able to talk on a real-time basis. Means, hello, hi Shubham, how are you? Okay. So, when you reach home, I reached home at 6 o'clock. Communication has to happen between two people. That is what we call as real-time communication. So it's not that I will talk now and somebody else will reply after 1 minute. So that is non-real time. So what is the difference between the real-time traffic and non-real-time traffic? Let us take emails. Now email is basically non-real-time traffic. Why? Because okay, I can send a mail to you now, I can read it tomorrow also. The ecosystem doesn't require you to reply to the mail instantly. Okay. So any kind of data exchange, that type of traffic is not real-time traffic. But in case of voice, if I am calling you and if I say hello to you, I need to hear that hi from you instantly. And thereafter, whatever we converse about or whatever we talk about, that also should be audible to you. And whatever you are saying from the other end, that has to also be audible to me. So that is the requirement of the real-time traffic. Okay. Now, having said this, there is another aspect which the VoLTE requires presently. But fine, in due course, it may not be required. But as of now, it is required. And that is what you call as interoperability. Now, what is interoperability? Now, VoLTE system should be able to communicate with the lower version systems. For example, the VoLTE system should be able to communicate or exchange information with the traditional 2G, 3G systems also. So that is what you call as interoperability. That means you are able to operate within VoLTE and also outside the VoLTE domain. So a combination of these two is called as interoperability. Okay, got it? So these are the three requirements. One, now why the real-time traffic scenario came in? Because see, point is, we know that traditionally, data was not real-time traffic. And TCP, IP and packet switching. So when we talk about packet switching was not actually real-time. There is some delay. And why that delay happens in packet switching? That is because of the fact that there is certain amount of time that is required for packetization and depacketization. So when you pack a data in a packet, that is what we call as packetization. So the time that is taken for the packetization is called the packetization delay. Now when you open the packet and retrieve the information out of that packet, so that process is called depacketization, and the time taken is called the depacketization delay. So the entire transfer of the packet, that is transfer of information through packet, means it has to undergo a packetization process, then it has to get transmitted from point A to point B, and at point B it has to be depacketized, means the information piece has to be retrieved from that packet. So in case of data traffic, let's say email, video and all these type of things, okay, I'm not talking about video, let's say email or any kind of data which you are sending. So that is non-real time. Say your WhatsApp, it is not a real-time traffic unless you are doing a WhatsApp voice call. That's real time. But non-real time means you are sending something on the WhatsApp. Now, there's nothing about it. So I can send you a WhatsApp, you can read it after 1 hour. So the ecosystem doesn't require you to respond immediately. So that is non-real time. Now, packet switching, that is VoLTE is basically not circuit switch. It is based on packets, data packets or voice packets to be very specific. Now, when packetization or packet switching started to get involved in the voice scenario, this delay was something which was basically a thorn in the flesh. It was basically a problem. So how the delay of packetization and depacketization has been removed? By introducing a new protocol which is called RTP or real-time protocol. Okay, so RTP. So now, what is special about the voice packet? Now, in the entire ecosystem of your network, a lot of packets will be going. There will be some data packets, some voice packet. Now, in order to support real-time traffic, in order to support real-time voice communication between two parties, right? You have to prioritize the transport of the voice packets. Okay. So how will the ecosystem understand which packet it should give priority? So now we all know that when you are traveling on the road, if an ambulance comes behind you, you need to give that ambulance priority, correct? And how do you do that? What does the ambulance do? Ambulance gives one header, that siren. And when you hear that siren, you move your car towards the left or right and give ambulance a space to go. That means what exactly you are doing? Technically, you are actually giving him priority. So these voice packets, they will be having an RTP header or a real-time protocol header, which directs the routers which are in the ecosystem to give priority to those packets. Okay, so it will have the RTP header, and the RTP header will indicate that this is a voice packet, so please give it priority. So if the voice packets get priority via real-time protocol, then the packetization and the depacketization thing, which used to actually cause the delay, or which could have actually disturbed the real-time voice traffic, that is taken care of. So it is TCP and RTP which is used as a transport mechanism for the VoLTE calls. So the real-time header tells the ecosystem, fine, this is a voice traffic, so this needs to be given priority. And RTP also minimizes the packetization and the depacketization delays to acceptable levels so that the communication appears real-time. So these are the why I am spending a little bit of time on this, because you need to understand what is real-time traffic, right? Real-time traffic means something which is spontaneous and instantaneous. Non-real-time traffic means something which may not be instantaneous. So I send you a WhatsApp photo, you might see it after 2 hours. That is non-spontaneous and non-instantaneous. But when we talk about a real-time thing, that means it has to be spontaneous and instantaneous. Now, since VoLTE is a voice technology, it requires spontaneous and instantaneous response. Hence, the VoLTE traffic has to be real-time traffic. So in order to make the TCP packets real-time, a protocol called RTP or real-time protocol is used. And the RTP header is embedded in a TCP packet, which makes sure that the ecosystem understands that these are voice packets and these need to be given priority. Just like you give priority to ambulance when you are driving on the road, or you give the priority to any MLA or the minister's car which is having a red a light or a blue light or whatever it is, or you might give way to the police cars. So obviously all the other packets which are traveling in the ecosystem, so ecosystem has to make sure that they give you the priority. They give the priority to the voice packets, and those are basically going to be the RTP packets. And interoperability, of course, we need interoperability because still the entire ecosystem is not all VoLTE ecosystem. Since it is not all VoLTE ecosystem, then obviously it is going to make sure that it has to be able to communicate with the lower technologies. Okay. So this is the background about the VoLTE. Now, okay. Now in this is the basic architecture of VoLTE. Now see here. Now so this is your handset and this is your eNode B. Okay. Now of course VoLTE uses something called the MME, the mobility management element, and which is a node which is lying inside your packet core. And the packet core network which is there in the 2G, 3G, that is enhanced. Okay. And this new packet core which supports 4G is called an EPC, or an evolved packet core. Now what is the evolution? Now the thing is that in the 2G and 3G system, we used to have a GGSN and an SGSN here, okay, which are the basic packet core nodes. Those are getting replaced by the S gateway and the P gateway, which are equivalents of GGSN and SGSN in the 4G scenario. Then we have got a PCRF, policy and charging rules functions, okay, that is controlling the QoS, which I was talking about. And then this very intelligent and brilliant element is there, which is called the MME, the mobility management element. So this is the this MME is acting as the VLR. So in the VoLTE scenario or in the 4G voice call scenario. Okay. Now the evolved packet core is connected to the IMS core, this pink block here. Okay. And here we have got the IMS nodes, pure VoLTE nodes. Down below in the yellow block, we have got the CS core nodes, or the circuit switched core nodes, okay, which signifies that the VoLTE architecture supports interoperability. So when the call has to move back to circuit switched core, or when VoLTE subscriber has to call a non-VoLTE subscriber, then the call has to come out of VoLTE and enter the CS code. So that is also another case of interoperability, number one, right? And number two, of course, when a VoLTE subscriber moves to a scenario where he does not get the VoLTE services, then his services need to be catered from the CS side. So in both the cases, we call the thing interoperability. Okay. Now let us examine these small notations here very, very carefully. Now, here we have the mobile station, or what you call as a handset, right? Now this is your eNode B. Now you see here, I told you the other day that the solid lines are basically user interfaces, and the dotted lines are control interfaces. So the interface or the link from the eNode B to the MME is called S1. This is the control link, wherein the eNode B and the MME exchanges call setup type control messages. And here you see there's an S1U here. S1U means the actual voice traffic or the data traffic will flow through the user interface. So user interface means payload. Okay, it is basically the actual data which is being carried. So that is, those things are all transferred through the user related interface, and all the control interfaces are the dotted ones where only control or signaling related information is transferred. So signaling related information between LTE, that is the eNode B here. Okay, this is the eNode B, Okay, the evolved node B, and that is exchange, that is linked with the MME with the S1 interface. Okay, now you have entered the evolved packet code. Inside the evolved packet code, there are certain interfaces. Okay, now let us say the MME to S gateway. Okay, this interface is called the S11 interface or S11 interface. Okay, now this is again a control interface you see here in the dotted line. Now, the interface between S gateway and P gateway, okay, this is what we call as an S5 interface. Now, S5 interface, it carries control traffic as well as the user traffic. So basically, it is a user interface only. It doesn't carry any control traffic, but there's a provision made for it. So now this is again an user interface, a solid line. Now you see, when this P gateway is in your home network, okay, this interface is called the S5. Now when the S gateway contacts a remote P gateway, okay, right? Say for example, in a roaming scenario, then this interface will be called S8. So S5 is the interface between S gateway and the P gateway, where the P gateway is at home. And S8 is the interface between the S gateway and the remote P gateway. Is this clear to all of you? Clear, team? Okay. Now, this is the very important interface here, the MME connecting to the HSS. Okay. The HSS means it is the equivalent of HLAT in the 4G domain. And this interface is called the S6A interface. Now, why do you think the MME needs to connect to the HSS? See, in the 2G, 3G scenario, the VLR has to connect to the HLR because of the interrogation and all these things. But in the 4G scenario, in the VoLTE scenario, this MME is acting as a VLR. So it has to perform interrogation with the HSS. Right? It has to ask the HSS, bhai, kaun sa subscriber hai, where is this, who is this guy? So how does it do that? It will do that through the S6A interface. Right? This interface is called the S6A interface. Another very important is between the P gateway and the PCRF. Okay. Now, this interface is called the GX interface. GX interface. Okay. And this interface is used by the PCRF or the policy and charging rules function node to guide the P gateway about the quality of service. What is the thing? For example, he will say, okay, Mr. Modi is coming, so he has to be given highest QoS. So who will tell that to the P gateway? The PCRF. And how will that communication happen? Through GX. So when some user traffic comes here, this P gateway will ask the PCRF, what kind of quality QoS you want me to give him. So he will tell him that, okay, he's a VIP guy, so we give him, Z plus security, Z plus. Now, if some ordinary guy is coming, you will say, okay, we'll give him the normal thing, QoS. Okay. Right. So this is about your EPC. Now, slowly we are getting into this P block. Now, this pink block here, and we are entering the IMS core. And here you see two very important interfaces, the RX interface and the GM interface. Okay. The GM interface is between the P gateway and the PCSCF or the SBC, to be very specific. Now we have already learned that PCSCF is proxy CSCF. Okay. So proxy CSCF is the node through which you are entering the IMS core. So that is called the proxy CSCF. Okay. And the interface between the P gateway and the control interface between the P gateway and the PCSCF is called the GM interface. Now, effectively, if you look at it like this, when okay, I'll just try to show it through a laser pen. That is going to be easy. So when an user is actually latching on to the IMS core, he's using this type of a path. So this entire red line between the user equipment and the PCSCF here is actually your part of your GM interface. Okay. So this part of this dotted line is basically P gateway to PCRF, but actually this entirety this traffic we call as GM traffic. The other very important interface is the PCRF and the SBC interface. That is what we call as the RX interface. Now, why does the PCRF require to be connected to the PCSCF or the SBC? The reason is that the PCRF is only governing the quality of service. So what QoS needs to be given to the user, that is determined by who? By the PCSCF, by the PCRF. So PCRF obviously has to communicate. So now where is the GX interface used and where is the RX interface used? Now in case we are talking about browsing and data traffic, okay, then the P gateway will consult the PCRF through the GX interface. Now in case it is VoLTE traffic, then obviously the PCSCF or the SBC will consult the PCRF through the RX interface. So RX interface is the important interface for VoLTE. Now, if you look at this solid line here, which we call as an SGI, or this is the interface. This is again a user interface where from the data traffic goes to the internet. So whatever browsing you are doing from your mobile handset, it follows a path like this in the 4G scenario. So it will follow this path, and it will move to the internet. Okay. If it is a voice traffic or VoLTE traffic, it will move through this path. Okay. It will move through this path to the PCSCF. Then it will have a bidirectional link. Okay. It will consult the PCRF and the PCRF will give back something, the QoS, and then slowly it continues the registration and moves here and moves out. Okay. In between, of course, the interrogation happens with the HSS. So we'll come to all those things, how the registration happens and stuff later on. So I'm just trying to show you the path of the traffic, which we will be studying at a later stage. Now, there's another very important interface, that is the interface between the IMS, okay, and the HSS, and that interface is basically called the CX interface. Okay, so it is basically the interface between the IMS, to be very specific, between the CFX and the HSS. That's the IMS and the HSS. So this interface is called the CX interface. Now between the SBC and the CFX, right? The SBC and the I or SCSCF. So CFX means your I and SCSCF. We have got the MW interface. Okay. Between the IMS core network and the TAS, we have got the IST interface. So this is where, now you see, do you remember the ISD signal, the insert subscriber data? Okay. So the IST interface is used for exchanging of the data between the IMS and the TAS. Okay. So with the any other application servers which are connected to the IMS, you have got the SH interface. Okay. And if you look at this yellow block, this is the CS code block, right? Now here you see that the HLR is connected to the MSS via the map signaling, and between the map and the MRFP, okay, the media resource function. So we have got the H.248 or Megaco. This is what we call the Megaco protocol, Media Gateway Control Protocol. Now outside this, you have got your famous IZOOP. So when the call is happening inside the CS code, this is a total TDM link. Okay. Now this part, when the P gateway is talking on the voice side, this protocol which you see here is RTP. So this is a special case of TCP, which is called RTP, where the priority is given for the voice packets. Okay. So these are the basic interfaces of the VoLTE network. So now let us see what happens here. This is the terminal part. This is the access part. Okay. This is the core network down here. And this is the application part. So these four basic layers are there. Core network means the EPC plus the IMS core plus the CS core. So if it is fallback call, then it will go to a CS code. So this in entirety is the core network, and beyond that you will have the application servers. So you see how the VoLTE has been evolved. So initially it was like this 2G, 3G, and all these things. So first thing that came into the picture was the HSS. So the slowly we went on to the NDS architecture, which could support the requirements of an HSS. Now this is what you see as a typical 2G, 3G network. What you see right now, and then slowly what has happened, you have done an EPC. In the evolved packet code, you have put in an MME there, which will control the mobility related functions, right? So this is basically LTE, which was data only. This was still not capable of voice. The next part which came in was a CS fallback for voice. So it was able to make sure that the calls fall to the CSFB. So initially when VoLTE was not there, but only 4G technology came in, then what used to happen was that the calls used to happen on 3G and the data or the internet used to happen on the 4G. That was the initial stage. And then came the VoLTE, where now you see this change here. Now we have got this IMS core control network. You have got the PCRF. You have got the SBCs and the CFXs here. Okay. Then came the SRVCC. SRVCC means single radio voice call continuity. Now what does that mean? That means what? Irrespective of your radio technology, your call has to continue. Irrespective of your radio technology, your call has to continue. So if you are moving, say you are in a 4G coverage, you are talking on VoLTE. Now suppose you move in a scenario where actually your 4G coverage is not there, your call should not get disconnected. It should drop to the next lower generation technology, that is 2G or 3G. And this particular methodology of call handling is called SRVCC, or single radio voice call continuity. So that means your call has to continue irrespective of the radio technology that you get. Okay, now what are the components added in VoLTE? TAS, the telephony application server. Okay, the CFX 5000 for the call session control functions. Okay, the PCRF, of course, for the QoS part, and PCRF is of course a part of the EPC. It's a part of basically the packet core network, which is interworking in the VoLTE network, because it controls the policy and charging rules phenomena. And then you have to get it integrated with the CS core network. Okay, the IBCF and the MSS and all these things. You have to put it into the CS core network so that you can support the interoperability part. Okay. Right. So we'll stop here. I would like to now take any questions. I will not make it very heavy because these are all new things. So I'll just open the house for any questions that you may have. Do you have any questions till whatever we have learned right now? Yes. Yes. So so go through these things. We will. Okay. Okay. So for tomorrow again, when we start, we will again go back to this architecture and we'll check whether you have got any doubts or not. Okay. So for the timing, so tomorrow we'll continue a little bit more on the VoLTE architecture. And once we are all clear about the nodes, components, and architecture, then we will go for the VoLTE call flows. Okay.
Okay. Yes, sir.
Okay. So thank you, guys. Okay. Until we meet tomorrow. So I will do bits and pieces. I'll not put in too much heavy traffic inside your brain, because then your CP will go in overload and that will become a problem. So we don't want that to happen. So slowly and steadily, we'll learn the things. And the message for Sushti, Shubham, and Ramaya, that, and even Ritvik, so you have to now start. I think Shubham and Sushti and Ramaya, Ritvik, all of you guys need to go in a huddle. And I think today I have told some of you that what you need to check in the MSS and the HLR and all these things. So please exchange your notes and tell them that people who are already having the system access, they should try to check those things and relate with whatever knowledge they have gained so far. And then slowly you will be able to sort of understand how things are happening. Okay. So I think Shubham and Srushti, you please take the lead today what I have discussed. So please discuss with your friends and tell them that this is how you need to check the different things. So that part also needs to happen, and I think try to have your logins so that now you can check different things and you can relate to what you've learned. So learn about that. Start logging into the system. Okay, and I think some of your seniors would be definitely assigning you small things, okay, to do small jobs which you need to do. So you start doing that, so you will gain confidence of the system as well. Okay.
Okay, sir. Yes, sir.
Okay,
Okay.
sir.
So thank you, team, and
Thank you, sir.
Thank you, sir.
Thank you, sir.